Greetings everybody, I want to give you a sneak preview into the reverb delay unit that I'm building. The first section of the unit is what we call the differential input, and this is what a typical XLR input section looks like that uses an XLR input. The other section of the unit is a spring drive unit, and this is a specially designed spring drive that I designed to make sure that the spring get a constant drive. And let me demonstrate what I'm talking about. Right now we have a 100 millivolts input, and this is what the amplitude of the output is. And look what happens when I go to 200 millivolts. What you find is a quick rise, but if you notice the output comes back down to approximately the same as 100 millivolts. Look what happens when I go to 100 millivolts. What you see is a quick fall off, but it brings back up the output to the desired amount. The next section is the spring recovery circuit. This is what recovers this reverb sound or the reverb effect. The next section is the delay unit of the reverb. The other sections we have here working with is a 2 XLR output, and this is what we call a differential line driver that drives a XLR output. The other section is the filter section, and this is where we have the high pass, low pass section of the filter. The other section is the RMS detector, and what this does, it converts a AC voltage into a DC voltage to control the spring drive. This is what we call the power supply part. And this section is what we have the printed circuit board layout. So after I put the parts exactly where I need them, then I can go ahead and tell the program to wire up the board. And it's now making the traces and putting all the wires in the best position. Nobody sits down anymore with a soldering iron and really building printed circuit board because it leaves too much rooms for mistake. Some of these parts are so critical that it have specific soldering temperature over a given time. And if some parts, like if you was working on something for a cell phone, they needed say to be soldered 100 degrees for 5 seconds. Anything over that is going to fry the parts, and this is why in this day and technology we don't build circuit boards or build anything by sitting down with a soldering iron and doing it like we do it in the old days. It leaves too much room for mistake, and these mistakes usually turn out to be very costly because after you build a printed circuit board and you get it back, you might find that you probably put instead of a 2.2K, you put a 22K. And it just leaves too much room for mistakes. So no one really build a printed circuit board or building electronics by really pretty much sitting down and soldering. And the good thing about printed circuit boards is very direct, and you get the same thing each time. Now the board has finished wiring up, it found one error, right? And it's saying that these two parts are too close together, these traces are too close together. So I'm not gonna fix it. It got rid of the error, and it checked the board and says that the board is working properly. Now this is what the board looks like after it's finished. After it's finished routing it, and this is where all the parts would be placed on. The other section of the board that I want to introduce to you is the front panel, the front and back panel. Um, this is where we're going to have our one line input, two line output. We're going to have our power transformer, and this is where we're going to have our input module that you could put in a 110 to 100 and sorry, to 240 volts AC, depending on what country you are in. This is where we're going to have the knob section with the different controls that effect you're going to be having. Thank you very much for looking. This is just a sneak preview. Thank you.